Okay, hey, welcome. We are going to talk about section 4.2, matrix multiplication. This is a class live recording, so if you are interested in being part of the video, speak up. If not, you can definitely hold your questions until the very end. But I might ask you a couple different things, and if you feel comfortable being in the video, then you totally can be. First off, two types of multiplication we're going to talk about. First type is called scalar. It's when we take a number on the outside and we multiply it to everything on the inside. It's super easy. I feel like it's super easy at least. Let me show you the first example. I'm going to show you all the work, and then most of you will probably be like, oh, I can just do some of this in my head. So if you notice here, we've got a matrix and we've got the number 4 on the outside. That means that we're going to multiply every single element in this matrix by that number. So really, I'm saying that I have like 4 times 2, 4 times 1, 4 times -3, 4 times 3, 4 times 0, 4 times 4. So 8, 4, -12, 12, 0, 16. Most of you will probably be able to skip that first step, but that's kind of like the math behind it. Give you a minute if you want to copy it down. Remember, since this is going to be a video, if you do want to go back and view it at any time, all you'll have to do later on is once I put it into the system, you'll just hit play. You can fast forward, you can rewind, you can pause. Okay. All right. Try example 2 on your own. Take a minute, see if you can figure it out. Is anyone interested in sharing what they got? Go ahead. -3. Yes. Multiply all the numbers by -3. Six. Positive. Okay. -24. -3. Okay. And 45. Good. Hey, you're all right. You're all right. That was good. I think it's just because you were trying to go through so fast. I think you slow it down in your brain a little. Work out. Any questions at all? Scalar multiplication, like I said, not super stressful. The next form of multiplication that we are going to do is a little bit different, though. Okay. The way I look at it is with matrix multiplication. The very first thing that we have to decide is whether it is actually possible or not. So, if you look at the dimensions, for instance, I've got these two matrices here, matrix A and matrix B. If I'm multiplying A times B, the middle dimensions must be the same. Meaning the columns on the second one and the rows on the first one both have to be the same number in order to multiply. If they're not, say for instance, watch this. If I switch B and A around, B is a 2 by 3, A is a 4 by 2. These two numbers don't match, therefore it's not possible. So I don't know if you guys remember in geometry we learned this word called commutative. It's whenever you can switch places and things still work. Doesn't happen with matrices. You have to check both ways depending on how you're going to multiply. So if it does work, like if A times B is, we've got a 4 by 2 and a 2 by 3. The columns and the rows for the middle part are good. Does anyone have any idea what the new matrix would look like? Okay, the new matrix for this would create a 4x3. And I'm going to show you how to create that, that new type of matrix. And guess where I get that from? I get it from the rows and columns that I had before that were left over. Yes? It always goes rows by columns. So if you want to do like I do the hand gestures, rows by columns. Yeah. So you can do whatever you want to, but rows by columns. Yeah. It's like giving a catcher giving a pitcher a sign, basically. Like kick off, and then I want you to throw a fastball. Okay, so procedures. How to multiply a matrix. Multiply the elements of each row of the first matrix by the elements of each column of the second matrix. Then add these products. I've actually split up example number 3 into all 4 elements that we're going to solve for, just to show you how each piece fits. I usually do another type of hand gesture. I take my left hand and I go from left to right. Okay, so if you are with me right now, if you take your left hand and left pointer finger and go left to right, I know some of you are going to think I'm weird, and then take your right hand, okay, and go top to bottom. We are going to add and multiply using this method. I know it's like trying to pat your head and rub your tummy at the same time. It's kind of fun. All right, so finding the product. First off, we've got this first matrix. It's a 2x2. And the second matrix is a 2x2. The middle terms are good. They're both the same. So what we're looking to do at the very end is we're looking to create a 2x2. It is, but if you take a look, we're looking for the outside terms, 2x2. It just so happens in the example I already have everything laid out, so it kind of shows it. Okay, so here's what I want to show you, which is really neat, is if I'm looking at my row here, I'm looking at what I call the top, and then this is the left side. So that's how I get this first element that I'm going to have the location at top left. The way this is going to work, and I'm going to do this hopefully in green and red since we're getting towards the holidays. We're going to multiply -2 times 4. And then we're going to add it to 5 times 2. So we'll end up with 2. Notice what I did there. I start off at the very left, start off at the top, multiply, and then I'm going down. That's why I use my pointer fingers, is I'm going up, multiply, add, multiply. And that gives me my top left element. Next up, I'm still on top, but I'm looking at the right side. So that's how we get the top right. So again, I'm going to take my first top left, okay, and then my top of my right. So -2 times -4. Plus 5 times 6. Which will give me 8 plus 30, so I'll have 38. Then I'm going to go to my bottom. So this is bottom left. So that's how I get my element for the bottom left. So 3 times 4. That's how I start at the top again. 3 times 4 plus negative 1 times 2. So 12 minus 2, which should give me 10. And then my last one here, I've got bottom and right. So I get bottom right. So 3 times negative 4 plus negative 1 times 6, which then ends up giving me negative 12 and negative 6, so negative 18. And then I would just put those all into one matrix. And most of you are probably going to be able to do this all in one matrix too. That's usually how I work my system out. But that's your final answer. Now here's the deal. If you have a middle, then you're going to put, top middle or bottom middle or however you want to do it. I have a different problem in here that I'll show you as well. But really, once you get the pattern down, it's not super difficult. It's just practice, a little bit of repetition to try it out first. Okay. So again, take that left finger, left to right, take the right finger, going top to bottom, okay? And that's just saying about it, it's not commutative. And some properties, it can be associative, distributive, and it does have the 0 property. You know what? Let's go back to some scalar stuff first. Why don't you guys try examples 4 and 5, and then we'll go to another matrix multiplication problem. So what I'd like you to do right now is try example number 4, try example number 5. We'll go over them real quick, and then we'll go back to multiplying matrices together. Yeah, go ahead and try 5 as well. Hopefully that's what you got for example number 4. You had to use the correct C. On example number 5, you do want to multiply first, then add. Questions at all on example number 4 or 5? Everybody okay so far? Give me a thumbs up. All right, nice. Okay. Example 6, find B times A. I'm going to show you, I'm going to kind of get you started. Okay, 2, 5, negative 2, 1. So B is 2, 5, negative 3, 1, negative 6, 0. A is 1, 4. All right, so there's B and A. First thing that we have to check is, can we multiply these? Take a look. That first one, what type of matrix is that? What are the dimensions? 3 by 2. Yes. And the other one is a 2 by 2. Okay, so since these match up, we're good. So our new matrix should create us a 3 by 2. I want you to try it first. See if you can create the new matrix. I'm leaving room there because I'm going to show work. I'm going to show a lot of work. But I want to see if you can do it first. See if you can create a new matrix. So just start at the top and go down through. I'm going to give you about 2 minutes to see if you can do it, and then I'll slowly start to guide you, and we'll kind of figure out what's happening. Okay, for your first top left element, if you got -1, you are off to a good start. Let me erase this real quick. I'll show you what I'm doing. Okay, so I've got the 2 and a -3. And then I've got the 5 and the 1. And so that's going to be in my first top location. So 2 times -3 plus 5 times 1. Then the next part, I should have -3 times -3 plus 1 times 1. See how it's middle left? So middle left. -3 times -3 plus 1 times 1. Then I've got the bottom. So -6 and -3 plus 0 times 1 goes in the bottom left. Then I'm doing the same exact thing. I'm just using the other column. So 2 times 2 plus 5 times 2. -3 times 2 plus 1 times 2. I'm sorry, 4. That should be a 4. It should be a 4. Because I'm using this 4 right here. 5 times 4, 5 times 4. And then -6 times 2 plus 0 times 4. Notice my columns I put in my parentheses. It's like there's a pattern going whenever you're solving. And then you just do your addition and subtraction, which is hopefully the easier part of this. So the first one's -1, and then 10, 18. And then on the other side, I've got 24, -2, and -12. Questions at all? I'll give you guys some practice on those tonight as well. I've only got a few more examples that I want to show you. Now, hey, take a look. Here's the big difference. Look at example 6, B times A. Look at example 7, A times B. So we'd have a 2 by 2 and a 3 by 2. Is this possible? No. Not possible. I'll give you a second if you're trying to catch up or keep up, or maybe you erased, you just made one small mistake. Is DE defined or undefined? That's the same exact thing. Is it possible or not possible? We're going to skip that one because it's very similar to number 7 here. I want to take a look at number 9. Number 9, at a bake sale, cookies come in bags of 3, 6, or 10. Each bag contains either a chocolate chip or a peanut butter cookie. The matrix shows how many of each type of cookie bag was sold. How many of each type of cookie were sold at the bake sale? So if we take a look at each of these, they kind of form a matrix with the number of bags sold and the number per bag. So what we're going to do is we're going to use these and use matrix multiplication to determine how many of each cookie were sold. So first off, let's take a look and see what our numbers here. This is a 2 by 3, and this is a 3 by 1. Oh my gosh, those check out. So we are actually going to create a 2 by 1 matrix. Now you're probably thinking to yourself, Mr. Stewart, how can we create a 2 by 1 matrix on these? But it's actually very, very simple. Remember the rows? We have to multiply our row by our column. Well, if we only have one column, we're only going to have one element, or 2 types. We're going to have a top and a bottom. So in this case, if you look, we're going to take that first 12, we're going to multiply it by the number of bags, which is 3, plus 4 times 6, so our middle, plus 7 times 10. Then we're going to do the same exact thing with our peanut butter. 10 times 3 plus 11 times 6 plus 4 times 10. And so the first one there, we have 36 plus 24 plus 70. So we have 130. And in the other one, we have 30 plus 66 plus 40, which ends up giving us 136. So what this means, we have 130 chocolate chip cookies and 136 peanut butter cookies sold. And then that's all that I have for the notes.